Good afternoon and welcome to you all. It gives me a great pleasure to introduce our speaker, Mr. Ajay Chaudhary. Ajay Chaudhary holds a BE degree in civil engineering from University of Roorkee, which is now IIT Roorkee, and MTech in water resource engineering from NIT Kurukshetra. He is a member of the Mott MacDonald Hydro Management team with over 25 years of international experience in the hydropower sector. Particularly, he is responsible for leading the development and commercial management of the hydropower businesses for South Asia, Europe, Africa, and the Americas. Ajay has facilitated financial closure of many greenfield hydropower projects with a total installed capacity of whooping 1.5 gigawatts. He has knowledge and understanding of all the aspects, including technical, environmental, and social, contractual, and permitting related to generation, transmission, distribution during the development and operational of hydropower projects. He has undertaken projects and design management role with multidisciplinary and multicultural teams, engaged on major hydropower projects internationally from pre-feasibility, construction, supervision to operation. He is familiar with thermal, wind, solar, and other renewable power, and has worked in numerous countries. So list I think goes on and probably is over 16 to 18 odd countries where he's got experience in. It gives our IGS Mumbai chapter great pleasure to introduce our speaker. Just on a personal note, Ajay Chaudhary and I, we are undergraduate Roorkee batch classmates. So there's a small big story. I think Ajay probably still remembers how we actually got reconnected after Roorkee days. This is before the WhatsApp and other social media still had not come up. So Ajay worked in a city called Brighton. So he used to take his evening train from Brighton back to home in London. And I worked in a very small town. It's more like a village which was not far from Brighton, and it's called as Louis. And I had to take a train from this town to back to my home place. But occasionally, if I lose my train, if I miss my train, I had to come to a bigger city, Brighton. That's where Ajay's office was. We still never knew that we were in the same place. Incidentally, on that particular day, Ajay Chaudhary and I, we were on the same coach. And he was probably half the coach ahead and I was behind. Okay, I could clearly, his. I heard his voice, and I years later. I mean, that's a point where I knew Ajay Chaudhary is somewhere in the coach. So today itself, when you hear him, you will experience the same because his voice is quite clear and he speaks very well. With this, I like to, hand over the floor to Ajay, and we like to hear what he says today. Okay, Ajay, over to you. Just give me a minute. I'll just make you a presenter, please. So I think now you're able to share your presentation. Yeah.
So Ashish, thanks a lot for a fantastic introduction, and it's my pleasure to make a presentation of what I may have learned over the last 25 years doing hydropower. And it's a pleasure also to be presenting to some of the geotechnical engineers or hydropower professionals who have joined here. I really appreciate it. And I don't remember that particular train journey, frankly, but it's great to know that you remember it so vividly.
Yeah, I remember.
Anyway, guys, I don't know what has happened. So can you see my screen?
Yes. It's not in presentation mode yet, but yes.
I will do the presentation mode, Ashish. I think, first of all, before I start my presentation, I have a small video about on a project which I worked in Peru. I spent about 7 or 8 years on that project. It is a 450 megawatt odd project, and which had extensive big high dam, 200-meter odd. It had extensive tunneling of the order of 30 odd kilometers, I would guess, with the biggest tunnel being diversion tunnel of 13-meter diameter. It had a surface powerhouse as well as access roads of the order of 30 kilometers, and a reservoir of whatever I should say, 17, 18 kilometers reservoir. So it was a major project, something of the order of $1.5 billion. And I worked on that project for roughly 8 or 9 years, which included 3, 4 years to achieve a financial close because it was developed by a private sector entity, and then managed the construction of that project for another 4, 5, 6 years, and then helped on the operational side of it before the project was kind of uh, uh, project was sold to another party, So I have a small video which kind of, can you see the video, Ashish?
Yes, it's playing very well.
Yes. So this gives you a little feel for this, what hydropower projects are really all about. They are mega civil works project. It is a power project, but people need to remember that 80-90% of it is a civil project. So this is more about showing you the scale of the project, so that when we discussed about the risks as well as what are the appropriate mitigations on a hydropower project, we actually get some context. So this vertedero mean is a spillway. This was a concrete face rockfill dam. So you had to think about spillway issues. This is about the plinth on their CFRD, which is, this was fascinating how people were hanging on the mountains 200 to 50 meters above the riverbed level. One need to understand the infrastructure which also goes into these projects. So this was on-site fabrication or whatnot, workshops. These are the batching plants. I think this is the big tunnel I was talking about. This is one of the portals. Another bridge. This was one of the access roads for which they built a tunnel. This was fabrication of the penstock. This is the surface powerhouse. This was the scroll case. This is the pit. So that kind of gives you, I have got another very small video which could be very interesting. I'll just show you what sometimes happens when you are tunneling, you know. So this was, face was excavated, and suddenly you realized that there was some kind of material. Don't ask me. I'm not a geologist. I'm a civil engineer and a water resources engineer first. But this is fascinating. This is not something I had seen before. So there was some kind of material over the edges which was coming out. You know, a disaster was averted because nobody died, or you know, people were aware of it that the moment this started happening. So anyway, I guess you get the impression of how big hydropower projects are, and now you can see my full screen, Ashish.
Yeah, it's there. Yes.
So now to start with the actual presentation, risks and mitigation. We have seen how major civil works are there. So in a hydropower project, all those who are aware, I think majority of us are engineers. Typically, you have a major dam, then you have a tunnel, then some kind of a surge shaft, penstock, and a powerhouse. It could be surface or underground. So these are major civil works. You know, the M&E equipment which actually generates power is not that influential, or sometimes not as important in the success of a hydropower project as the civil works associated with it. And this presentation is not about, however, not about just the civil work side of it. What is more important to make this project success is far more than just designing a project. So what I have learned over the last 25 years and working with banks, etc., is to make a hydropower project, which is major infrastructure, you have to get a lot of things right if you don't want surprises during execution. So I'm presenting this presentation with the perspective of a lender, somebody who is going to invest money in the project. And somebody who is going to invest in the project will look after many aspects. And if you put their perspective in designing any infrastructure project, I will talk about hydropower, but if you talk about any infrastructure project, then you will get a good project at the end of the day. So what are the contents of my presentation? So we'll talk about, this may be true for other infrastructure projects, but typical project structure if you have to do project financing. This is a little different from if the government develops it. But typically, what is the project structure if you have to develop the project in the private sector? Then you have to talk about what are the key risks. And here we will discuss the risks in multiple aspects. You know, so we are not only talking about technical risk, but we're talking about technical, environment, and social, and a few other risks. Then we talk quickly about what is lender's perspective on risk, what is the big picture for lender's engineer, and some conclusions. So this is a typical project structure, which quite a lot of you may be aware of. Project company could be a special project vehicle. There are project company advisors, some sponsor who is putting equity in the project. There's a lender's engineer, which the lenders want to opine on whatever documents have been prepared, or technical feasibility, bankability of the project, etc. And obviously, then you have to start considering who is going to take off, whether there will be somebody who's willing to pay or have the credibility to pay. Who's going to be the contractor? What kind of contractor? And who is going to provide O&M? Who is going to operate the plant? Whether they have the right experience to operate the plant to get the maximum revenue out of, or generation out of the plant. So it's a typical project structure, but each node of this project structure is important to understand. So if sponsor is credible, the odds of getting financing is high. If the sponsor is not credible, difficult. Same with O&M provider, off-taker, contractor, whosoever you talk about. So then just look at, I have put the top 10 technical risks here. So one of the most important one is design and constructability for the project. You have seen how what major civil infrastructure it is. So the question is, what is the extent of geological? So when you start evaluating a hydroelectric project, or for that matter, any infrastructure project with significant civil works, the question is the extent of geological, geotechnical investigations appropriate as well as reasonable for the stage of the project? So you may do some investigations at a conceptual stage, but then you keep on adding additional geotechnical, geological investigations. And this potentially, I should say, is one of the most, there are other risks which are as important, but geological and geotechnical risks is the most important as far as a hydroelectric project is concerned, or for that matter, other infrastructure with civil predominance is concerned, And what, as a practitioner, what we have found out is that not enough investment is made in geological, geotechnical investigations. Sometimes geological and geotechnical investigations are not done appropriately. What you don't want is to do sampling in a manner that or for example, do boreholes in a manner that you don't get good core recovery. So appointment of the right kind of geotechnical investigation company is important. How do you take samples for laboratory test so that they don't lose moisture is important. What kind of test you do, etc., etc. And on that basis, what kind of model, geological model, geotechnical model you prepare is important, so that you understand what are the geological, geotechnical challenges on the project. Then the question is the design suitable? And these days, it is as important in terms of consideration for climate, because of change in climate, the PMF for which we design a dam, that may be far higher than what you design it for. There are significant dam safety issues. We recently had a major flood in Uttarakhand, and we are aware of what are the challenges when a landslide happens. And a small hydropower project was virtually wiped out, and the big Tapo one, Vishnugad, is going to get delayed, or even if you can retrieve it, who knows? And then can the project be built within budget and time? I will flip to the second slide, which kind of shows what we within my company look at in terms of the investigations, first of all, but then how we present that information for everybody to understand. So this is some kind of a 3D model which we prepared so that once we are aware where is the dam site, we are also aware about the various faults. What is the fault trace on ground, whether it is visible or not, whether there are any potential hydrothermal alteration zones, what is the bedding, what is the discontinuity, where is the approximate groundwater level. In fact, in this picture, you can also see the real photograph where we are trying to match with the geological, geotechnical model. And this was something which we have done in the past. Now we are moving to something a little different. I will stop this and show you a video, and then you can see what I'm talking about. Ashish, can you see that?
Yes.
So this is another of our projects. So now we have started looking at this software is called Leapfrog, and we are taking historic boreholes are shown in red, green are from 2015, and blue are from 2019. We use borehole surface mapping and as-built construction drawings to model this geology. And when you see orange, that's quartzite. When you see purple, it is dolerite. When you see pink, it is phyllite. And when you see blue, it is limestone. So this kind of model, yes, you can, this is a video for presentation purposes, but you can use it to do a lot many smart things. So the things as far as presentation is concerned is moving significantly in that respect. How you present the geological, geotechnical investigation information to various stakeholders is evolving, around the world. Now we all are working through kind of 3D models, no longer working on small cross sections, or because what you realize is that when you do these models, then you can see intrusions or whatnot as appropriate. So coming back to my my presentation, it's important before we start on a job like this to understand the geological, geotechnical context for all project features. So for a dam, you may do a borehole, you may do a seismic refraction, you may perpendicular to the dam axis, along the dam axis, you may do some kind of what I should say, some kind of seismic refraction, as well as some kind of edits on the two abutments. For powerhouse, similarly, but for a reservoir, you may do a geomorphological study for landslide, which can be desk based on some aerial photos or whatnot, and sometimes these days you can do it on Google also. And
Ajay,
then
sorry. Ajay, it's not in presentation mode.
it's not in presentation mode.
No,
I
the screen is still small.
just give me a sec.
Actually, we can see the total number of slides. It's making us very happy that you have less number of slides. I think it's making all of us very happy.
Okay. So you can see now in the presentation mode.
Yes.
So as I said, so effectively looking after geological, geotechnical investigation of each of those project features, whether it is the dam, the tunnel, the search shaft, the powerhouse, underground or surface, and then about access roads, what kind of investigations you need that, because sometimes on some of these projects, we forget about the access roads, and sometimes access roads 20 kilometers or 30 kilometers with multiple number of bridges, drainage structures, etc., could be a project by itself. Uh, and then we need to be aware of that access roads sometimes could be 10-15% of the cost also. So it is important to look after each of those aspects, and not to forget about the quarries, because people forget that you get whether the material for the dam is available in the project site itself, that decides the selection of the dam, etc. So there are a host of those kind of issues. I will not go into too much detail. You can ask questions if you later on, but people need to think about the design and constructability of the project from the start, and geological, geotechnical investigations play a very important part. Second, obviously, is the operability, because sometimes we forget that this needs to operate for 100 years, maybe, especially a hydro project. Will it work and will it continue to work? So you need to design it for long term. As I said before, who will be responsible for operation and maintenance, because that's very important. The third key technical risk is the risk allocation. As you would have realized, geological risk is the most important risk, and that is something which no party wants to take. So contractors who don't want to take, the banks don't like it. What they want is an EPC contract, and whether you can really sign an EPC contract with major civil works, that's always the debate which keeps on going. FIDIC has recently come out with an Emerald book, which may help, but the jury is out there. The majority of the hydroelectric projects in India have got delays. Sometimes very few have got commissioned on time, and that is not true for India only. It's potentially an issue around the world because of geological, geotechnical surprises, because initial investigations have not been done properly. There are cost escalations and there are delays, and which party is able to take that risk is always very challenging. Uh, uh, Trying to transfer all the risk is not appropriate. You pay the premium, but you reality may not be able to transfer the risk of unforeseen ground conditions. I think the fourth more important risk is energy projections. Uh, Hydrological data needs to be clarified, understood very well. That's a major mistake which happens when we do analysis on hydrology. Is it appropriate? Was there enough data? Were the gauging site appropriate, etc.? Second one is obviously environmental flow projections. In the old days, there was a norm to take 15% of the annual average flow as an environmental release. But I think those times have kind of gone. Now it is more about what receptors, how they will be affected, will decide how much environmental flow you have to release. Environmental flow release is not constant, it is seasonal now. So in January, you will release an X amount, but in February or March, you may release a different amount altogether. And it has to understand, it is to be understood, even the operation, how the project will operate. You can't change the operation of the flow or the downstream flow regime so much dramatically that the flora and fauna will be adversely affected. So you need to consider, there are a lot of IFC guidelines, World Bank guidelines on environmental flow now. And if you're not done properly, you are looking for delay in financing pretty quickly. Obviously, now there is IHA climate resilience guidelines, which need to be considered for considering climate change aspects. That is true for generation, whether there is likely to be a trend in generation profile, or or generation flow is likely to increase, sometimes is possible, or is likely to decrease in the horizons of 30 years, 50 years. And similarly, what is the impact on flood? Whether it will increase because of high increase in temperature or whatnot, or whether because of climate change, the hydrograph will become more peaky, which means the PMF is higher. Maybe the total volume of flow may not change, So all those aspects are very important in climate projection, energy projections, as well as for dam safety aspects. The fifth one is obviously losses and availability. Typically, hydropower projects have availability of 98%, 99%. But if you are in Himalayas and sediment is an important consideration, how well you have designed the project because of sedimentation, availability can easily be far lower, because you were trying to remove the turbine or change some of the underwater parts, etc., etc. And what are the losses which are typically happen on between at the station itself? So people forget that you lose 1.5-2% of energy within the station itself. And obviously, then looking at the capex within benchmarks, the major issue for us is always what is the contingency on a major project like this, whether 10% is appropriate or 25% is appropriate. Similarly, OPEX, there are some rules in India, which is kind of in the right ballpark of 1.5%, depending on the size of the project for the of capex as an OPEX expenditure. Obviously, the third is, or eighth is, the quality. Can it be built with acceptable quality? Is the contractor experienced and competent? That's a very important issue also, because choosing the wrong contractor for a major project like this has major reputational issues also for lenders, because these days health and safety and environment and social aspects or management during construction can derail the project during execution pretty quickly. I have got many projects where because of health and safety and ENS issues, it is sometimes no approval for payment of disbursement. So a sponsor is requesting 100 million to continue the project, and lenders are not doing the disbursement because the health and safety issues on the project as well as the environmental issues are not being managed the way they should be. And 10th is obviously the interconnection. In India, it's very typical, when you start the project, somebody tells you this is the point of connection, and then this point keeps on changing because the project is delayed and somebody else is providing the interconnection point. The related issue obviously is whether there is capability to evacuate, whether proper power system studies have been done, load flow studies, transient studies have been done or not. So this is kind of a gamut of key technical risks, but there were others also. So what are the ENS risks? Obviously, you have IFC performance standards. The question is whether all the studies are compliant with various performance standards 1 to 6, 7, or whatever they are. IFC performance standards are kind of ubiquitous, but different lenders, it is important, but different lenders have some nuances too and different emphasis on various issues. Permits is another area, whether suitable permits are available for the project or not. For me, these days, however, biodiversity is becoming and ecosystem services is becoming the key item, which can easily derail a hydroelectric project, because of the effect a hydroelectric project has on the biodiversity. You need to understand, are there any protected areas and species? And if there are, can you provide some offsets which are reasonable? So if you are able to provide offsets which are reasonable, then the project is okay. Otherwise, there are major challenges. Ecosystem, again, what is the community's reliance on natural resources and how they may be impacted by the project? This is very important to understand. If somebody is doing and mining in the reservoir, how the community will be affected. So it's not only about the community which is resident there. Even if they are using the land, then also they have rights, under IFC standards, etc. And if there is resettlement on these projects these days, if there is anything more than 2,000 people to be resettled, it becomes a major issue to get financing, because and especially if there are any indigenous or vulnerable groups. We have talked about the downstream flow regime uses and impacts. Obviously, reservoir management is a major issue because you're creating a reservoir, there is a water quality issue in the reservoir, and whether that will affect the community. So if you have a reservoir, whether that, obviously the quality by any chance is poor, then whether it is a community issue in terms of malaria or whatever, it depends on which part of the world you are developing this hydropower project. Climate change we have talked about. Then the environmental social management plan. These days, it's a very, very important document. Trying to close this out takes months and months, and it considers about capacity and capability of various parties. And then labor. I think more and more, previously what used to happen was that a project will be financed, and after that, all the due diligence will happen very hard till the financing. After that, everybody will forget from the lenders. But these days, it's not the same. During construction also, there is so much of focus on all aspects of ESMP and how that feeds into, particularly labor also. So whether all the labor force have got contracts in place, what kind of accommodation they are getting, how their health and safety is taken care of, what kind of sanitation facilities they are getting paid or not paid. We can keep on talking about it, but labor and environment social management plan during construction is a major issue during execution of the project these days. So majority of us who are kind of technical always think about these projects being, if we can fix the technical and the ENS issues, we are done. The challenge we have is that those are in some ways for lenders sometimes become a second order issues, because those are the ones which can be fixed if you do it properly, but there are certain issues which are more challenging or difficult to fix. So when we talk about government risks, what are the transboundary disputes? Is there an existing treaty or intergovernmental agreement which is important? What additional requirement this needs to be understood? If there is a transboundary issue, it needs to be understood. Political change. So this becomes a very important issue. Will a change in government affect the policy framework? So if somebody may have got the concession agreement to develop the project, but if somebody else comes in, how watertight that concession agreement is, will they go back to the drawing board again? So is there a government political risk guarantee? So this is something World Bank does, African Development. So all the major banks provide some kind of a government political risk guarantee these days. Obviously, the third one is when you're developing a project like this, which is a physical infrastructure, which is given for a tenure of 30 years, 35 years by any government under the concession agreement, which is going to stay there for 100 years. What role the government is going to play in due course, and whether government officials, department responsible to the project developer and supportive of the project. A lender will not touch the project till a big major IFI especially will not touch the project till he gets a direct request from the government that they are keen to develop this project and they would like those lenders to engage on the project, or start their due diligence. Projects where there is a one-stop window for various approvals does help in developing these big projects. Don't forget that some of these projects of the size we are talking about could be, not in India, but in some places could be sometimes 7 to 10% of the GDP of that country. So these are multi-billion, hundreds of millions, billion-dollar projects in parts of the world where these projects could be very important politically also. So it's important to understand the political context. Obviously, license and permits, government committed, because for site investigations you need so many permits these days. Just for site investigation, but for construction you will need again permits. So unless and until the government is fully committed to support, it becomes very challenging. Then security. If the project is in a part of the world where security is an issue, then that could be a showstopper in some ways. Corruption we know about. And then the financial risk. One is about the electricity market. So there is the usual agreements called power purchase agreement and offtake agreement. It's kind of a little easier in India. There is kind of regulatory. If you manage your ENS and technical risks, as well as some of the government risk, at least on some aspects, in India it may be a little easier, but in some other parts of the world, negotiating a power purchase agreement or an offtake agreement with a credible offtaker is a big challenge. And power purchase agreement has to be such that it is back to back with all the other contracts which may be signed, whether on the O&M side or whether on the EPC side. Another issue is foreign exchange, because majority of these projects are in parts of the world where the currency is not traded. So nobody wants to take a currency risk. So what is the currency of payment? What kind of hedging mechanism will take place? Regulation we have talked about. India, there is reasonable regulation. One can argue whether it is over-regulation or not. So what is the approach to contractual concession agreement? What is the government commitment we talked about? Cost escalation. Cost escalation could be because of foreign exchange issues also, if they are not appropriately dealt with, and also because of, as we said, because of delays, because of not appropriate contingencies, could be because of geological, geotechnical investigations not being properly done, and then there is dispute between the contractor and the sponsor or the borrower. We talked about off-taker creditworthy, and then obviously sovereign guarantees we talked about, and is MIGA available, which is an important requirement in some of the developing world. We talked about the sponsor, are they trusted partners, who is the lead arranger, etc. That's from the bank side. And then the last one is obviously the suitable provision of contractual penalties to encourage contract performance. So now coming to what is lender's perspective on risk. We have discussed about the 4 important risks. What I always find interesting is there is no dearth of money really. There is dearth of good projects, and good projects in locations where they are easy to develop. What they are interested in, does the project comply with their stated policy guidelines and standards? This is very important. So lenders are all about reputational risk in some ways. They don't want NGOs sending them emails about, oh, this went wrong, that went wrong, kind of. One important thing, does the project achieve positive measurable outcomes? That is a demonstration whether it will improve sustainability, of the project. Will it improve, support the net carbon agenda, which is currently very important for banks, because majority of them have signed up to it. Are the base case assumptions of financial model satisfied? They're just interested in, because they're not looking for huge returns, the banks. They are just looking for whatever small percentage which they need to, they need the return, they need the money to be returned to them, and with small amount of percentage as for taking the risk. As we discussed, are there any reputational risks? So for all practical purposes, the big picture for lenders engineer, we should be aware that lenders want to finance the project but protect their interests, which are more reputational rather than anything else, and compliance with some of the standards they have signed up to. We need to have an understanding that lenders do not benefit from a project performing above expectations. This is important to understand. They don't benefit if the project, they are not looking for upsides. They care very little for upside. They are only looking at the downside. And therefore, I, who works as managing lenders engineer assignments on, I have at the moment 5 or 7 of them at the moment, which I am dealing with. We have to remain independent. And that means that sometimes sponsors' view has to be supported also. So our role sometimes ends up being risk identification and communicating how risk can be mitigated. It's interesting that we are paid by the sponsors. So in some ways, they are also our client. Our job is to manage the sponsor, which is always very optimistic, and lenders who are very conservative. So we have to walk the line in some ways. So conclusions. Lenders have a mandate to achieve positive measurable outcomes on a project. A continuous healthy dialogue with the lenders is very important. I think it's all about the nuance of various issues. How material those issues are is very important. Lenders engineer like us is sometimes ends up being an arbitrator and to harness the healthy tension between the sponsor and the lenders, so that their approach to project development, construction, operation, and perception of risk is managed effectively. Thank you. Any questions?
Yeah, thank you, Ajay. I see right now. Okay, if there are any questions, please you could either type it on chat or raise your hand, please. Yeah, Ajay, I have a very simple, question. It's more like, towards uh, what challenge in terms of, when you say that geotechnical investigation being not adequate. So wherein do you see that, the inadequacy or the challenge lies? Because such sites invariably it will, any amount of geotechnical investigation would be proven to be inadequate. So wherein you would say is adequacy of such an investigation?
It's a very interesting and difficult question to answer, uh, and that is why I said about different stages of the project also, but you need to still, for example, on a dam site, uh, you may like to do at least one borehole in the middle of the rivers to at least know what is the depth of the foundation, because that's a construction planning issue also, because you want to excavate to the, depending on the type of the dam, you want to excavate to the rock foundation. So what you really want is as many boreholes along the dam axis at least, and if not possible, then at least can you do it in a barge on or something like that, um, in the middle of the river, and maybe a few inclined holes from the abutments, to make sure. So you have to obviously think through how many, depending of the particularities of the project, think through how many real number of boreholes you, because site investigations are expensive, and you have to kind of draw a line sometimes between, so you do a walkover, you understand how good the abutments are, you look at the dipping of those, of the, as I said, I'm not a geologist, but you look at the dipping in terms of how deep that dip could be, and where the foundation may, because rivers are formed into the weak geology, of put it this way, so we need to understand how much excavation has happened because of the river flowing, or where the rock foundation is. So there are multitude of ways into do as much which is considered appropriate at any given moment in time, so, but I would guess in a dam site, we typically end up between 7 to 10 boreholes, so that you get a feel for, and then what you also do is do some seismic lines, which is along the dam axis, as well as cross, so you can get a footprint of the dam in as sensible a manner as possible. So then the odds of finding some features will be less. I will not say it will get removed, but it will be less. Similarly, on the headrest tunnel, the zones of weaknesses could be at the low points, where you may be worried about because of hydrostatic pressures, blowout, etc. So you will do there, but you will walk along the tunnel to see some features on the ground, to see where are the major faults, if any, and how they will pan down onto the headrest tunnel, along the headrest tunnel alignment. Sometimes cover is an issue on the headrest tunnel also, and then to avoid the low points, you have to push the headrest tunnel deep into the mountain, which sometimes increases but at least you don't have to create an aqueduct at one of the drainage points along the headrest tunnel alignment. We end up doing a lot of surface mapping also when we work on projects. So it's no easy answer, but on a major project like that, uh, in UK, the amount of investigation happens is sometimes ridiculous, but in India, compared to that, the amount of investigations is far less, or other parts of the world also, and people assume that there will be 15-20% cost escalation or whatnot when investigations are carried out, or when construction happens, so you have to either do enough investigation, when I say enough, to so that you can use the surface features as well as the uh, investigations which you've done, to get as much of a sense of what the geology is going to be, and then create 3D models as I showed on the two pictures.
Yeah. Just one actually. There's one question additional. See, in Maharashtra, our state, we have a lot of rainfall in a very short period. For example, right now for last 3 days, we have been having excessive rainfall. So there are, I think, plenty of remote areas where it's a very practical problem, which I want to ask you. They have a few villages collectively. They build some check dams along the the channel flow where the water flows. But unfortunately, majority of these dams do not last beyond 6 to 8 months. Ideally, they would like the water to be there, in the holding pond for maybe for an year, so that when the next monsoon comes in, is there a solution, or have you come across such things wherein you feel that we can do something about it, because it's a very real problem, and especially remote parts of Maharashtra where there is water scarcity in summer, and the poor farmers, they have nowhere else to go. So
So
that's
I
something
think
which I think your input will be helpful. Yes.
I think we need to I personally need to understand the context. Are you suggesting that those check dams just fall over when high monsoon comes?
No, no, the water the holding capacity dries off. So in maybe 6 or maximum 8 months, there is no water.
Okay, so
And
this is more of a hydrogeological aspect, if I'm not wrong, because that's a issue on a hydropower dam also when we are thinking of reservoirs, because if there is limestone, for example, and there is cast, etc., then there are significant leakages from reservoirs. So one need to understand the hydrogeological aspects of wherever you're creating these kind of structures, and what holding of water they will happen or not happen. This is without understanding the full context, but I think hydrogeological studies potentially is the answer to understand better how long that water will be retained.
yeah, okay. Okay, so I have one, I think speaker, I have unmuted Professor Murthy. You're there.
Yeah, thank you, Ajay Chaudhary. So I'm a colleague of Ashish Juneja at ID Bombay. One of the very, very interesting and very, very complex problem what you presented today. So we always, I should say, after listening to you, I understand that we are like a frog in the well. We always look from geotechnical point of view, but especially these kind of projects what you presented, the geotechnical or maybe the structural component is very, very limited. Most of the issues, what I want to ask you here, we have one of the projects in Andhra Pradesh, where I think you must be knowing that Polavaram project, which is
Yeah.
a multi-purpose project. For decades, for the decade, the project was not completed for several reasons. One of the things what every time comes is this is between, I should say, though it is in the state of Andhra Pradesh, uh, some of the so-called catchment area is in the Orissa state, and these areas are fully covered by tribals, okay, or I should say the so-called far away from the society. And every time the inundation comes, a big deal, and non-technical things, especially how to manage these people. And every time the collector goes to them, convince them that no, you just leave that area, your area, and we provide you an alternative site where you can construct your houses. Villages and villages, I think you must be knowing that villages and villages be completely removed before the project is constructed. So what is the solution for these kind of issues? Because this is something like political things always come into picture, socio-economical issues. So now, is there any solution for these kind of issues? Because see, what I noted now, this particular project is a government project, and probably government, because every time government changes, there are policy changes. But when it comes to a private project, for example, you must have dealt several private projects. So in the because you need to get a clear what I should say land, or I should say the catchment area, unless you get a clear picture on what is the area available, whether the real area in the catchment area, whether it is available or not. I think it is next to impossible to go for this kind of projects. Project will be completed tomorrow. People will not leave the villages, and then everything will come to a halt. So how do these pictures, how do these situations are really handled when it comes to private projects? That is my.
So, Mr. Murthy, it's a very delicate and an important issue. I'm going to work very soon on a project where the government is insisting on a height of dam, which may result in 10,000 people to be resettled. And I know that for that number of people, no international financial institution will touch it because they will perceive it as a major reputational issue. The government is thinking of that project with that height of dam and with that kind of resettlement, so that actually that dam becomes in some ways a dam safety project, so you can regulate the dam, you can regulate the flood, because they have existing catchment with 3 existing hydropower stations on that catchment, and then by having a high dam with flood regulating features, yes, it will result in 10,000 people to be resettled, who incidentally don't live in that valley anyway because they have moved out, but their houses are still hanging in the valley, or are there in the valley. Actual people who are maybe living maybe 2,000, 3,000 at the moment. But the moment the project comes up, all those 10,000 will move in to get compensation because of the project. So what will happen is that people may have to, if they want to take that project forward, and that project also has been there in the pipe for 20, 30 years and has never progressed, is because of this classical issue between how do you optimize between what you need technically and what are the environmental and social issues. The bar on indigenous people, vulnerable people, is nowadays very high, and you can only build these projects now if you have the right communication, right dialogue with tribals, indigenous people, etc., etc. As I said, it's about the dialogue. What typically happens is, I can tell you this. My first project in India was Maheshwar hydroelectric project. That was my first project. I designed the spillway structure, all the power dam, and all kind of things. That project is still not commissioned. Tell you this much. The project which was upstream of that, Omkareshwar, which NHPC did, is already commissioned. And the reason Maheshwar didn't commission was, or because it was delayed quite a lot. That was a time when Medha Patkar, etc., were very active in the Narmada Bachao Andolan when World Bank walked out of hydropower in 2000 something because of that. And they used to come and sell all kind of stories in terms of which had no technical bearing, but that affected Maheshwar. Also, Maheshwar was not affecting ENS that big time. Sadar Sarovar was definitely. And you said yourself on Polavaram also that the project is in Andhra Pradesh, but it will affect Odisha. It's a transboundary issue between states. You know what happens between some of the rivers in the south, between Karnataka and Tamil Nadu anyway, in terms of what releases, etc. So in a transboundary issue, first of all, the 2 state governments have to work together, whether how to align their interest, and then talk to the vulnerable groups. There is no other way. Otherwise, it was a political roughshod of a political will to say we are going to do this project. When the water starts rising, people will have to move out. That's not the best way to develop these projects, but if there is a political will about it, then some countries, those projects do happen in the way which is not appropriate, but they do happen sometimes, But none of the so put it this way, a project like Polavaram can be done under the state with the state government or whosoever going roughshod over all the ENS matters. It is very unlikely to happen with funding from places like World Bank or other IFIs with the issues which are there existing on Polavaram.
Yeah. Okay, Ajay, there are two more questions. Just 1 second. One is by Shri Pathanke Saab. He's the, I think, one of the most senior most in member of our local chapter. His question is just 1 second. Just trying to that. It's in the construction cost. What percentage is investigation cost?
I think on a typical, if I may say so, you typically need something of the order of 20 million pounds, something of the order of 20 million pounds to do on a major infrastructure project or a major hydropower also, something of the order of 20 million pounds for development. And I would guess, or you can say $20 million, it doesn't matter. Just we're talking ballparks here. Of that, I would guess, again, how well the access is or whatnot, it could be easily 4 to 5 million pounds or dollars for site investigation on a project which is could be half a billion, or 500 million. So put it this way, geological, geotechnical investigations could be 1 to 2% easy.
Okay. Thank you. There's one more question. Mr. Arun Kumar, please.
Hi Ajay, it's very nice to see you here. And
Thank you.
yeah, Ajay, I'd like to ask this question that you mentioned about this small hydro projects and the some 500 mega projects on which happened in Uttarakhand, where all the investigations have been carried out as per the protocol which has been mentioned over there, are there in the place. But this happened, and this happened because of Himalayan glaciers, things which sometimes happen. So if you had to do the projects in Himalaya, then what kind of things have to be done in a first go, or if we had to develop only one project, of course, then what solution? And if we had to do a series of projects, then what solution? So that's one part. Second part, just to add, like you mentioned about this issue of R&R issues, which has been always a delicate issue for any kind of water body structures that displace the people. What about the experience of China, where when they did the three gorges, when they have actually rehabilitated and resettled people first before they went into the real construction of the project? How about that kind of experience, or placing them as a part of the project's equity if it is a financial project, if it has got a financial bearing, then how about putting them as a part of stakeholders in terms of recurring benefits or recurring revenue which the project may have, and then they can be part of that. So with these two things, over to you.
So I was not expecting an easy question out of you, Dr. Arun Kumar. You know the challenge is far better than I can even try to answer. I think as far as the Himalayan region is concerned, if you consider, and you have been on some of these presentations, if you consider the kind of studies which are being done, for example, on Upper Arun by World Bank in Nepal, and that is looking at all kind of safety issues with respect to bluff events, with respect to uh, formation of lakes and breach of lakes, how the glaciers melt or landslides. So if you are trying to do these major hydro in some parts of the world. I should say that these days we are spending a lot of time understanding landslide risk in the reservoir. We are all aware of the old Vajonth failure, where a big landslide happened just upstream of the dam and it kind of wiped out the dam itself. And dam safety and how it impacts the people downstream is a major issue these days. With PMF becoming peaky and with the glaciers melting in the Himalayas, I think what is important is to do a very good analysis of whatever are the risks in the upper Himalayas or some of these catchments in terms of, I think there are so many good satellite features, or these studies have to be done properly and understood very well before you even think of doing these kind of projects anymore. As I said, I don't have an easy answer to it, but the kind of extensive studies which are being done currently on Upper Arun with the right kind of specialists involved is the first starting point, which should be done if you want to not have a similar incident as happened in Uttarakhand. As far as China is concerned, we can't talk much about it. They can do whatever they want. A project like Three Gorges is unlikely to happen in any other part of the world, that easily. That is a very easy answer for that. But you are right about making the stakeholders participants in the development journey. The government has started looking about providing free power in India, for example. In some of the projects which we have worked, we have provided some kind of training to people so that they can get involved into the during the construction of the project and in due course operation of the project. Obviously, uh, the you have a difficult challenge of not overselling what benefits the local community will get or not get because of the project. Because if you try and oversell it, then also it's a problem. So you need to have a balance about consultation with the local community, how the project will benefit them, the number of grievance mechanisms issues which need to be sorted so that people are aware of progress of the project. We need to avoid over consultation, however, so that when the project gets delayed, people don't get fed up that they have been talking about starting the project for the last 5 years, but the project has not moved ahead yet. But unless and until the local community is not supportive, they don't see the benefit of the project, because typically these local communities, what they see is, I will give away my ancestral land, I will give away my ancestral home, my life will not change. They will give me a house which I'm not used to. For example, if you look at Terry, which is not the right example, the whole town was on the edge of the river, and now they are on the top of the mountain. Whether they got enough money, the change in profession, whether that suits them, okay. But otherwise, the way they were living has been completely changed. And those are the kind of things which matter, especially the adults in adult beneficiaries of any project like this, compared to the young who may have different aspirations. So how do you manage all those aspirations between the young and the adult is very important to understand. But it's all about communication, engagement with the community, explaining them the benefits, the wider benefits to the country, the benefits to them, how the project will help them change their lifestyle, etc. And if they buy into it, you have a project. If they don't buy into it, maybe you have another location where you can do that project.
Yeah, thank you, Ajay. I'm sorry, Professor Arun Kumar, I was not aware you're here. Very glad to see you, sir. Yeah. Okay, I think Ajay, there are no more questions. Okay, and